After this movie, students will be able to solve proportions and solve for rate and unit price. Do now. Try these 4 questions on your own, so pause the movie and resume when you're ready. Number 1, we have x over 24 equals 7 over 12. So we're going to use equivalent fractions in order to figure out what our numerator should be. Well, to get from 12 to 24, we multiplied our denominator by 2. Whatever we do to the bottom, we do to the top. So our numerator would be 14. 14 over 24 is equal to 7 over 12. Number 2, we need to figure out 8 over 15, what its equivalent fraction would be when it has a denominator of 165. So first, we'll begin by doing 165 divided by 15. And we get 11, which means that we multiplied our denominator by 11 to get 165, and whatever we do to the bottom, we do to the top. So m equals 88, because 8 over 15 is equivalent to 88 over 165. Now number 3 is a little bit trickier, because there is no factor that we can multiply 6 by in order to get 9 that's a whole number. We would have to multiply by a fraction or a decimal. So one strategy you can use is to try to reduce this fraction first and see if that helps. Well, 3/9 is the same thing as 1/3. So we didn't change the problem, we just reduced it to another equivalent fraction. So now we can say that w divided by 6 equals the same as 1 divided by 3. And now to get from 3 to 6, we multiplied by 2, which means that we're going to multiply 1 by 2 in order to find w, which is 2. So 2/6 equals the same as 3/9. And finally, number 4, to get from 2 to 6, we multiply by 3. So I multiply the 7 by 3 in order to get our t, which is 21. So 6 over 21 is equivalent to 2/7. Today we're going to be talking about proportions. As you may recall from previous years, a proportion is an equation that states that 2 ratios are equal. To find the missing value of a proportion, you can use equivalent fractions like we were just doing in our do now, or you can use cross products. Cross products is when you have your proportion, which are the 2 ratios set equal to each other, such as a over b equals c over d. Then what you do is you multiply diagonally a times d and b times c and set those products equal to each other. This is true for all proportions. And this strategy is very helpful when it's difficult to come up with an equivalent fraction. For example, if we're asked to solve t over 9 equals 5 over 6, we find that it would be hard to figure out how many times 6 goes into 9, because we will get a fraction or a decimal. And then if we try that second step of reducing 5/6 to see if that helps, we can't reduce 5/6 since it's already fully reduced. So this is a perfect example of when cross products is the most efficient method to use in order to solve for t. So we take our 6 and multiply it by the t, so we're multiplying diagonally. And we set that equal, let's erase that. And we set that equal to 9 times 5, which is 45. Now we have a one-step algebraic equation. 6t equals 45. Divide both sides by 6. 6 goes into 45 7 times. 7 times 6 is 42, which leaves us with 3 left over out of the 6. And we can reduce that to 7 1/2. So T equals 7.5. Now, quick side note. Please do not confuse proportions with multiplying fractions. On quizzes and tests, I always see students start to confuse these two concepts together since they do somewhat look similar and because you know that they have something to do with, products diagonally, either cross products or cross reducing. So for example, if we had y over 12 times 4 over 7, you're used to reducing diagonally. So 4 divided by 4 is 1, 12 divided by 4 is 3, and then you can multiply straight across to get y over 21. Notice how this is different than what we're doing, where there's an equal sign in between the two fractions instead of a multiplication sign, and instead of reducing diagonally, we are multiplying diagonally and setting those products equal to each other. Now you try these 4 problems. So pause the movie and resume when you're ready. So number 1, we start by multiplying diagonally. 4y equals 9. Divide by 4. And we get 2 1/4, or 2.25. Number 2, we have 6x equals 40. Divide by 6. 6 goes into 40 6 times, with 4 left over out of the 6. So x equals 6 2/3. Number 3, we have 7y equals 48. Divide by 7. 7 goes into 48 6 times, which gives us 42, and therefore there are 6 left over out of the 7. So we get y equals 6 6/7. And number 4, you can use the hint of reducing fractions first when you can. So notice we are not going to cross-reduce like we would with multiplication, but since these are each fractions that are set equal to each other, we can reduce the fraction, 18 over 50. So I can first start by reducing it to 9 over 25 if I divide them both by 2. And then I can go ahead and cross-reduce, so I have smaller numbers to deal with. 25m equals 15 times 9, which is 135. Divide by 25. $25 goes into 135 5 times, which gives us 125, so 10 left over out of the 25. And then we can reduce by 5 to get 2/5. So m equals 5 2/5. Now let's practice solving multi-step proportions. When proportions have variable expressions with more than one term, use cross products and the distributive property. So for example, if we're solving the proportion x plus 4 over 5 equals x minus 2 over 7, we're going to be multiplying 7 times x plus 4, but it's this entire quantity. So 7 times x plus 4 equals 5 times the quantity x minus 2. Now we start by distributing, and we get 7x plus 28 equals 5x minus 10. Get all the x's on one side, so we'll subtract 5x from both sides. We get 2x plus 28 equals negative 10. Subtract 28 from both sides, and we get 2x equals negative 38. Divide by 2, and we get that x equals negative 19. Now you try these 3 questions. Pause the movie and resume when you're ready. Number 1, we're multiplying 10 times the quantity x plus 2, so we put it in parentheses, which equals 14 times x. We distribute to get 10x plus 20 equals 14x. Get all the x's on one side, so subtract 10x from both sides, and you get 20 equals 4x. And divide by 4 to get that x equals 5. Number 2. Notice how I can reduce 35 over 7. So I always start to look to see if I can simplify the question at all. So instead of 35, I can divide by 7 and get 5, and 7 divided by 7 is 1. And now I can use my cross products. So 1 times the quantity y minus 15 is just y minus 15. And that equals 5 times the quantity y plus 4. So now I distribute, and I have y minus 15 equals 5y plus 20. Subtract y from both sides to get all the y's on one side, and you get negative 15 equals 4y plus 20. Subtract 20 from both sides, and you get negative 35 equals 4y. Divide by 4. We have a negative answer since it's a negative divided by a positive. 4 goes into 35 8 times, which gives 32, so there are 3 left over out of the 4. Okay, so we have negative 8 3/4. And finally, number 3, we have 3 times w minus 4 equals 5 times w plus 6. 3w minus 12 equals 5w plus 30. Subtract 3w from both sides, and you get negative 12 equals 2w plus 30. Subtract 30 from both sides to get negative 42 equals 2w, and divide by 2 to get w equals negative 21. Now let's talk about some real-world examples of when you would use proportions. The first example is an example of a proportion in a recipe. A lemonade recipe calls for 3/4 cups of lemon juice for 2 quarts of lemonade. How much lemon juice should you use for an 8-quart jug of lemonade? Well, we can set up a proportion. So we know that we're using 3/4 cups of lemon juice. Notice how I am labeling. For every 2 quarts of lemonade. So what I'm doing is writing down the ratio or fraction of lemon juice to lemonade. And then I'm going to set that equal to our other ratio, which asks how much lemon juice should you use for an 8-quart jug of lemonade. So the question is x cups of lemon juice over 8 quarts of lemonade. It is very important that you line up the units horizontally from one another when setting up a proportion. So I have cups of lemon juice and cups of lemon juice. I have quarts of lemonade and quarts of lemonade. Now we want the ratio of lemon juice to lemonade to be the same so that it's not too lemony or not too watery. Now we can go ahead and solve this by using cross products. So we do 8 times 3/4, 8 over 1 times 3/4. You can cross reduce since we are now multiplying the fractions. And you end up with 6 over 1, or 6. So this times this equals 6, equals 2 times our x. Divide both sides by 2, and you get x equals 3. And since it's in our numerator, the unit is cups of lemon juice. So you would need 3 cups of lemon juice to make 8 quarts of lemonade. And that keeps the ratio of lemon juice to the other ingredients the same. Now for an example of proportions in nutrition. A box of cereal weighing 360 grams contains 200 grams of fat. Find the number of grams of fat in the recommended serving size of 54 grams. So we're going to set up our proportion. 360 grams of cereal, so let's make sure we label since they're both using grams, has 20 grams of fat. And we're going to set that equal to x grams, or no, we know the grams of cereal, so 54 grams of cereal. We do not know how many grams of fat, so we put our x in the denominator. Notice how we have grams of cereal in our numerators and grams of fat in our denominator. Now we can go ahead and solve this proportion. 360 over 20 can be reduced, so before I use cross products, I can try to reduce my fraction. So I can start by canceling out the zeros, which is essentially dividing by 10. And then 36 and 2 can both be divided by 2, so we get 18 over 1. So now I have 18 grams of cereal for 1 gram of fat, and I have my 54 grams of cereal over x grams of fat. Now we can cross multiply. We get 18x equals 54. Divide by 18, and we find that x equals 3. So 3, the unit is grams of fat since that's in our denominator. So there are, there are 3 grams of fat in 54 grams of cereal. Now for an example of proportions in science. A canary's heart beats 200 times in 12 seconds. How many times does it beat in 42 seconds? So we set up our proportion that there are 200 heartbeats in 12 seconds. And we want to know how many heartbeats there will be in 42 seconds. Well, I can start by reducing 212 by dividing each one by 4. So I get 50 heartbeats every 3 seconds. So we want to know how many will there be in 42 seconds. Now notice, we can cross multiply here. Or, if you recognize that 3 goes into 42, you can also use equivalent fractions like we did in our do now. So feel free to use either strategy that you feel is easier or more efficient for you. So if I do 42 divided by 3, we find that 3 times 14 gives us the 42, so 50 times the 14 will give us x. So let's do 50 times 14. And we get 700. So the canary's heart beats 700 times in 42 seconds. And finally, an example of proportions with maps. The scale of a map is 1 inch to 10 miles, which means that when two cities are an inch apart on a map, then in real life they're really 10 miles apart. The map distance from Valkaria to Gifford is 2.25 inches. How far is the actual distance? So we can say that 1 inch is to 10 miles as 2.25 inches is to how many miles? And now we can use our cross products. So 1 times x is just x equals 2.25 times 10, or 22.5. So our cities, Valkaria and Gifford, are 22.5 miles apart. Now let's talk about rate and unit price. Rate is a special type of ratio. What makes it different is that it compares two quantities that have different units, and it also contains a denominator of 1. So for example, $2.95 per gallon is considered a rate because we have two units, dollars and gallons, and our denominator is 1, $2.95 for every 1 gallon. Another example is with speed, 55 miles per hour. We have two units, miles and hours, and our denominator is 1. We travel 55 miles every 1 hour. So with rates, your goal is to get a denominator of 1. For example, Lazlo makes 30 toy airplanes in 5 hours. How many toy airplanes does he make per hour? In other words, what is his rate? So, we know that Lazlo makes 30 toy airplanes in 5 hours. So how many toy airplanes does he make in 1 hour? Well, we have 30 times 1, which is 30, and 5 times x, which is 5, x. Divide by 5, and we get that x equals 6. But we want to know how many toy airplanes does he make per hour. So we're going to write this as a rate that Lazlo makes 6 toy airplanes per hour. Now you try the next one. Pause the movie and resume when you're ready. If you drive 252 miles in 6 hours, what was your average speed? Well, your average speed is a rate. You're trying to figure out how many miles do you drive in 1 hour. So we can write 252 miles in 6 hours equals how many miles in 1 hour? So we multiply 252 times 1 and our 6 times x and divide by 6. And we get that x equals 42. So your average speed was 42 miles per hour. Now let's talk about unit price. A package of Bahu gum has 10 gumballs and sells for $2.90. A package of Tycho's gum has 20 gumballs and sells for $6.20. Which is a better buy? So the Bahu gum is less expensive, but you get less gumballs. So we need to figure out per gumball how much does each package cost. So we're going to start with our Bahu gum. And say that we have $2.90. Money's always going to go on top for these since it's going to be dollars per gumball. So $2.90 for 10 gumballs. And I want to know how much money is it going to be for 1 gumball. So dollars per gumball. So we get $2.90 equals our 10x, divide both sides by 10, and we get that x equals 0.29, which means 29 cents per gumball. Now let's do Tychos. Tychos is $6.20 for 20 gumballs. So we want to know how much money is it for 1 gumball. So you get 620 equals 20x. Divide both sides by 20. And you get that x equals 0.31 or 31 cents per gumball. So now that we can see that Bahu gum is 29 cents per gumball and Tychos gum is 31 cents per gumball, we can say that Bahu gum is a better buy. Now you try. Pause the movie and resume when you're ready. An 18-ounce box of Lucky Charms cereals sells for $3.96, while a 22-ounce box of Frosted Flakes costs $4.62. Which brand is a better buy? So we need to find our unit price. So how much money is it per ounce? So we'll start with our Lucky Charms. And we know that it's $3.96 for 18 ounces, and we're looking to find how much is it for 1 ounce. So you have 3.96 equals 18x, divide both sides by 18. and you find that x equals 0.22, which means that it costs 22 cents per ounce for the Lucky Charms. Now, let's find the unit price of the Frosted Flakes. Frosted Flakes cost $4.62 for 22 ounces, so how much money is it for 1 ounce? Cross multiply to get 4.62 equals 22x, divide by 22, and you get 0.21, which means that it costs 21 cents per ounce. So that means that the Frosted Flakes is a better buy. Now let's talk about converting rates. A sloth travels 0.15 miles per hour. Convert this speed to feet per minute. So, when converting rates, we're using a concept similar to proportions, but we call it unit analysis, which also may be known in the higher grade levels as stoichiometry. So, we begin with 0.15 miles per hour. It is very important that you use your units. So we know that there are 0.15 miles per 1 hour. Now, in order to change from hours to minutes, I can go and multiply this by 1 hour over 60 minutes. Now, the reason why we do this is because there is 60 minutes in 1 hour, so technically this fraction is equivalent to 1, and when we multiply a fraction by 1, it does not change the fraction. The goal, however, is that since we are multiplying, now notice this is multiplication and no longer an equal sign, we are able to cross-reduce. And we can even cross-reduce units. So if you have an hour diagonally from another hour, those cancel out, and now I'm left with miles and minutes. So far I've got my per minute, and I now need to change miles to feet. Well, we know that there are 5,280 feet in 1 mile. So now I just have to figure out if I should put the 5,280 feet on the top or on the bottom. Well, in order to use our cross-reducing, I would need to get rid of the miles by putting the miles on the bottom, since miles here is on the top. So I would say 1 mile is equal to 5,280 feet. This cancels out my miles. And now I can go ahead and multiply these fractions, since my only units left are feet and minutes. So we can either multiply straight across the numerator and denominator and reduce afterward, or we can start to cross-reduce first. So I'm going to actually cross-reduce first to try to make some of these numbers a little bit easier. So notice how we have 5,280 on the top and 60 on the bottom. So we can start by canceling out our zeros, which is dividing by 10. And now I have 528 and I have 6. Well, each of those could be divided by 2. So instead of 528, we could say 264, and 6 can become 3. At this point, we can go ahead and multiply across our numerator and our denominator. So we have 264 times 0.15 for our numerator. And we get 39.60 feet, since feet is the only unit on the top. Over 1 times 3 times 1, 3, and the only unit left on the bottom is minutes. Now we have 39.60 feet per 3 minutes, and we want to know how many feet is that per 1 minute. So we can use our cross products and find 39.60 equals 3x. I need to erase that, one moment. Divide both sides by 3 to find what x is. And we find that x equals 13.20 or 13.2, which means that the sloth travels 13.2 feet per minute. A cheetah ran 300 feet in 2.92 seconds. Approximately what was the cheetah's average speed in miles per hour? For this question, it states that you may use a calculator. Well, we still need to set up our unit analysis or stoichiometry just like we did in our last question with the sloth. So we're told that the cheetah can run 300 feet in 2.92 seconds. And we're trying to change this to miles per hour. So we can start by changing our seconds. Well, think about some units that you know, or some conversion rates that you know that will help us get seconds to become hours. If you're not sure how many seconds are in an hour, you can change it from seconds to minutes and then from minutes to hours. So for example, if we know that there are 60 seconds in a minute, I'm going to put 60 seconds in my numerator and 1 minute in my denominator so that the seconds can cross-reduce. So now I have feet per minute. I'm still trying to get miles per hour. So now I'm going to multiply 60 minutes per 1 hour so that the minutes cancel out. And now I have feet per hour. So at least I have 1 unit the way that we'd like it to be. Now I need to change my feet to miles. 5,280 feet in 1 mile. I'm going to put the feet in the denominator so that it can cancel out with the feet that's in my numerator right now. And so the feet cancel out. Now notice how all the units have canceled except for miles in the numerator, and all the units have canceled except for hours in our denominator. So we do have miles per hour. Now this question said that we can use a calculator, so you can just multiply straight across the numerator, multiply straight across the denominator, and divide your numerator by your denominator, and you get an answer that is approximately, so I'm going to put a squiggly equal sign, which means approximately 70 miles per hour. So the cheetah's speed is about 70 miles per hour. See if you can try these two questions on your own. So pause the movie and resume when you're ready. Number 1. A fashion designer buys 4 yards of a printed fabric. How many inches is this? Well, we can take our 4 yards Oh, it looks like my battery has died, so I will not be able to write out the problem. But I'll talk you through it, so hopefully you'll be able to follow along verbally. Sorry about that. Bad timing here. So we have 4 yards of fabric. So we have 4 yards. We can multiply that by a conversion ratio where we know that there are 3 feet in 1 yard. So I'm going to put times 3 feet over 1 yard, because that way I can cancel out my yards since those are now diagonally from each other. Now I need to figure out how many feet are in an inch. So I can multiply that by 12 inches over 1 foot, so that the feet cancel out with each other. And now I'm left with just inches. So you should have in your numerator 4 times 3 times 12, which is 144, and you should have only 1 and 1 in your denominator, so 144 divided by 1 is 1, so your answer is 144 inches. And finally, number 2. You paid $21.60 for 5 yards of fabric. How much did the fabric cost per inch? Well, you start by writing $21.60 over 5 yards of fabric. Now we want to know the cost per inch. So I'm going to have to change the yards to inches. So I have $21.60 over 5 yards times 1 yard over 3 feet, so that the yards cross-reduce. Multiply that by 1 foot over 12 inches so that the feet cross-reduce. And now you can go ahead and multiply. And so your numerator, you have $21.60. In your denominator, you have 5 times 3 times 12. So go ahead and multiply that, and you get 180. And now I do need to figure out that if I have $21.60 for 180 inches, how much will it cost per 1 inch? So I can set up a proportion that says $21.60 over 180 inches, which equals x over 1 inch. And then I can use cross products. 21.60 equals 180x. Divide both sides by 180. And now I'm going to go ahead and divide $21.60 by 180. So I put 21.60 in my division house and 180 on the outside, brought my decimal up to the top. 180 goes into 216 one time, with 36 left over. Bring down the 0. 180 goes into 362 times exactly. And so we find that the fabric costs 12 cents per inch. So the answer is the fabric costs 12 cents per inch.